record 2. This is loading in. I'm gonna post the announcements. Post this. Post the office hours announcement. Where is it? There's this one. I'm also posting a blue sky one. Post. There we go. Oh, it's looking a bit. What is killing me? Is it the Visual Studio doing things? Go away, Copilot. I don't want this. There we go. There we go. I'm also gonna open. What is heavy? Like, is that here or is that on my end?
No, I think it feels good to me.
I wonder if it's because I opened Visual Studio.
Well, I mean, it's Visual Studio. It's quite heavy.
Yeah, but like it's not doing anything. Maybe it's like indexing stuff.
Visual Studio likes to analyze the project in the background and use 1,000,000 gigabytes of memory.
Yeah. No. That hurts. Anyway, hello everyone.
We have a raid.
We have a raid. Oh my god,
Yeah,
hello,
we're
Nuki.
raiding.
Thank you, Nuki. Gran is going with Schnopit. You know what? Actually,
Listen.
I literally had like a thing I wanted to talk about, and then I got another thing I wanted to talk about. There's like no multiple. No, actually, I do have like a follow-up on that one.
Okay.
Let me just make sure I'm like not dying. Everything's posted, so everything should be okay. Hello everyone. Can you hear us fine? Welcome to another episode of Resonance. I actually kind of lost exact count. I think it's like episode 12 or something like that. But welcome everyone. This is sort of like my kind of office hours slash podcast. I'm here like with Syra, who's from our like engineering.
Hello.
And we talk about, about general kind of Resonite stuff, and a big part of this is, you get to ask questions. Whatever we would like to know about Resonite, whether it's technical, whether it's, philosophical, the vision for the platform, whether it's, something with team, the platform in general, or even just like, other things, feel free to ask them in the chat. One thing, make sure when you ask something that you add a question mark at the end of it, that way it pops on our thing. And then make sure like we don't miss the question. We already have like 2 questions like popping up, well, kind of one, but like I'm actually gonna answer like because Grant is going Schnoppit again. So this is getting answered because I do have a follow-up on it, because last time we talked about it, like that made a ramble about made a big ramble about wave hacking, and I kind of want to do a little bit of a follow-up to it. But before like we get to everything, actually I think I said kind of everything. Yeah, so like make sure like you have a question mark. We do have also some questions from Discord, and I kind of wonder if we should go through them first, just to make it easier for people to find. So let me just open that up. And these are like relatively quick ones. So I say we probably go first to Discord, like we let like few questions pile up, but we're actually gonna address the Schnoppet one first. And I'm gonna make it this like super one. Oh, also thank you Trebek for a subscription.
Yeah, thank you.
But this is sort of like, follow up like to the rave hacking thing, because like one thing I kind of noticed with the comments is like a lot of people are like, because we give you warning, if you use something like rave hacking, your stuff will break eventually. We don't know like when, we don't know when. It might just, one day like we change something and it ends up breaking as a result, and there might not be a replacement for it. And we've got a lot of people saying like, well, just make it official, or just, like so a lot of people use it, so like, just don't break the stuff. And the problem with that is if we were to do that, they would actually prevent us from implementing a lot of things that you really want, like for example performance updates or the domains for building big worlds, because it now means we have to freeze part of the code, part of like something that's not even a design that is sort of like relying on. We cannot change it, and that kind of ties our hand for future development. So the reason like we give you the warning is because we know this will break. And it's not really a thing, that's like that you can debate about, like, because you're essentially utilizing something that's not even designed as a feature in the first place, and therefore it doesn't have any kind of provisions for maintaining long-term compatibility. And the analogy I would like to use is it's almost like us telling you not to do rev hacking for anything long-term because you end up kind of hurt. Is think of it like us telling you that you shouldn't run with scissors, because if you run with scissors, eventually you'll fall and you'll hurt yourself, you'll cut yourself. And you can debate it all the way you want, you can be like, well, just make scissors, that you don't get hurt with, like when you run with them, but then it wouldn't be scissors anymore, it's something that will happen and we're warning you because we don't want you to get hurt. But if you do that, you're not changing the physics of scissors, you're not changing what scissors are. Like, that's just the consequence, of what you do. So, keep that in mind. Like, it's something that, either we freeze the project, we stop kind of developing a lot of the things just to preserve that, or it's gonna break. And, those are, pretty much the only two options on the table, and, you have to kind of, we're not gonna freeze the project, we're not gonna stop develop things, we're not gonna, stop expanding it. Which means, that's not even an option for us. Which means the only consequence of that is that it will eventually break. And when it does break, there might not be a replacement because we, we might be having other priorities at the time. So that's just a thing, think of it as getting warning, don't run with scissors. Because that's kind of what you're doing in a way a bit. If you use rev hacking for anything that's long term, you're gonna end up hurt eventually. And it doesn't matter how much you debate, it doesn't matter how much you're gonna ask. It's just a consequence of what scissors are, because they are sharp, and running with them where you can trip and hurt yourself. So I hope that kind of makes it a bit easier to understand what is it about. But it is this is kind of my follow-up to the PSA.
Yeah, I think some people expect oh, when it breaks, they're gonna magically get an auto upgrade or something to any officially supported method. But the fact remains that it could break one day and there might not be any replacement.
Yeah.
Even one that you could implement yourself yet, because we haven't implemented that yet. And even if we implemented official collections and component access and whatever that you're trying to use ref hacking for,
that might take
if you're using ref hacking, your stuff's not going to auto upgrade to that. You are not going to get any auto upgrades, bar none.
And that's pretty much, the reason we give you the warning. Because, we know that's how it's gonna, turn out. That's why we're warning you. And it's up to you whether you take that warning, but if you ignore the warning, you might end up, getting hurt as a result. So, that's pretty much, if we knew that something we can easily upgrade automatically, we wouldn't be giving you the warning. We would make the commitment, to supporting it. For example, the most actually recent thing, which actually ties to the second PSA I want to make, but there's the new particle system, photon dust, which is a replacement for the previous, now legacy particle system. That's been a hybrid between Froox Engine and Unity, and photon dust is a completely custom system that works on a bit of different principles than the Unity ones. But whatever done through its development is actually spent a lot of effort making upgrade systems to convert it, and that's because the old system is designed for you to use. And because of that, we now make commitments to preserve what you made as much as possible into the new system. And we spent over pretty much over 2 months, just like making sure everything's kind of fixed up and everything kind of works correctly. So when something is designed as a feature, usually like its public interface, that will we will make efforts to preserve how that works. But for something, you need to kind of you need to kind of dig under the hood and you need to kind of work around some things. Usually that means that's not going to be a supported behavior. Like if you need to kind of like the moment you start kind of like feeling like you have to kind of pull the behavior you want out of it, like by kind of digging and hacking something, that should give you a pause and be like, is this like meant to behave this way, or like is this gonna stay behaving this way or not? Because in most cases it will not. But it also like ties to the second PSA. Photon does now pretty much like pretty much all of the compatibility issues have been fixed up. Like things now kind of convert like properly. Things pretty much like look the same. The system's like stable enough. Since January, we've been already suggesting people stop using the legacy particle system and switch to photon dust, because it came out of experimental before the month of February. And now that like the last few conversions have been polished up, we're gonna be removing the legacy particle system tomorrow. So tomorrow is gonna be gone. All of the things will automatically convert to photon dust, which means like we'll only have like photon dust going forward, and this will actually finish the major milestone of the performance update. Because if you remember, like from previous Resonance, or if you watched the video, there's like two major systems preventing us to pulling Froox engine out of Unity. One of them is the particle system, the other one is the audio system. And with this tomorrow, the old system's gonna be removed, and it's gonna remove ties to Unity, one of the ties to Unity. And that finishes a major milestone, which leaves the audio system. There's going to be others next. That's going to be a smaller project than the particle system, because it doesn't have as much complexity to it. Partly kind of like on purpose, just to kind of like make it easier to move out. Once that one is done, the actual work will be on the split, on like reworking how Froox engine communicates with Unity and pulling it into its own process, running with .NET 9. And that's what's going to give us like the big performance boost, because we're going to be using much better runtime. So just to recap, the legacy particle system is going away tomorrow. Then the focus is going to be audio system. Once audio system is done, we're going to be essentially working on the final part of the big performance update. So it's getting kind of, it's getting closer. It's getting relatively close. So I'm kind of like, myself like excited for it, because like ever since like we moved headless to .NET 9, it's been running like, the headless itself has been running like way better than before, than it was running with Mono. And I've been kind of joking, I want us to feel how the headless feels, because we've had, there's like sessions which had like 44 users, for example, all of it like pretty much full avatars that were not called on the headless itself, and the headless was still keeping at 60 frames per second. So we kind of expect like pretty big like performance jump from that move once the graphical client is able to utilize that runtime as well. So that's the other PSA. Do you have any PSAs before we move on to questions?
Let me think. I don't think I do. But I just share in your excitement for the splitting, as you've taken to calling it.
The splitting.
Yeah, like it's gonna be good, guys.
That's like what all this work is gonna be like building towards. So that's gonna be the big one. It's also gonna be great because once we do the split, and we use the modern runtime, like it's also gonna, open up so many more possibilities, because now we can use modern.NET, like, performance features, because it has stuff like, SMID intrinsics, it has way better, like, vectorization, it has, like, there's a lot of libraries that we kind of want to switch to that don't run with the old .NET, and we can't use them. So there's stuff like, there's like math libraries, there's like image decoding library. We can like,
Tracy.
yeah, oh yeah, Trace is a good one for like, performance, like tracking. We can synchronize to the latest version of Beppu physics, which also has taken advantage, of like the new features in .NET 9, or just the modern like .NET. So just being able to use modern runtime is also going to help a lot like with the future development, which is one of the kind of reasons why we wanted to go this way for the performance, like for the first big performance update. So yeah, it's very exciting. With that, I'm gonna get into the questions. I'll field the ones from Discord first. Actually, maybe, hold on. Let's see how many we have, because I already kind of talked a bit. No, we have a few. So I'll go do the Discord ones first. And actually I have to disable streamer mode so I can see. There we go. So Spobe is asking, when it comes to brushes, will there be in future some kind of feature to make it easier for desktop users to properly use them without whatever you draw with it getting warped in the curvature of a sphere, and also with very poor depth perception? For example, plane or 3D box that you can switch on to, draw it with whatever cursor frill inside of it. Yes, there's actually something I would like to add. Like, I'm kind of like thinking at some point in the future, just, giving the desktop, like, we gotta focus on a bunch of issues to give desktop like more love, and like being able to use brushes. I think it's gonna be kind of useful. One of the things I was actually even thinking in my head that it'd be kind of cool to do, especially once we do like more of the UI work as well, is being able to use brushes. Even for example within your dash, so you can like do sketches and notes, and then you save it to inventory, and you kind of use Resonite as a sort of like a notepad as well. Utilize the brush system for that, but pretty much like having a system where it's kind of aware, that this like tool shouldn't be like used like spatially with the hand model, but instead you should like you align it to a plane, and then you're just gonna draw on your screen. I do have on my list of like fun issues. I actually have like a support for adding support for what's the word, styluses. Like we have like pressure sensitive stylus and stuff like that, so you could actually use it. You could like use it like with those brushes, and it's gonna feed like the pressure and other parameters to them, because I think it could be like really powerful. So that's definitely something that I would like to put some more time into in the future. The next question is from Kali. Are there plans to add more permissions for users? For example, currently I'm nervous to use Protoflex now to change user's avatar, since many people would get frustrated with it and you need to opt out via special code instead of opt in. Yes, there's a number of things with like permissions. So like there's sort of two types of permissions we have right now. Well, we don't actually have right now, but the way we think about them. The ones we have right now, they're sort of like, soft permissions. They're kind of like, more high level. If you really want to, you can kind of bypass them, but they're sort of like, requests, like, please, like, don't do this, don't do that. Some of those are harder, so like they're going to be like verified, especially stuff that has to do with like changing people's roles, kicking or banning them out of the server. Those are like verified more on the data model level. There's a system we want to introduce in the future called hard permissions, and it's actually going to encompass a bunch of different things. There's multiple aspects to it. One is it's gonna, essentially specify who can mutate which parts of the data model. So if you, for example, have the world, you can set it, so like majority of the world, nobody can change, and it doesn't matter, how you do it. Even if you write like, modified client to try to change those things, the host is going to reject those changes because it's going to be like, you don't have right permissions to this part of the data model. And there's going to be like, a basis for a number of different kind of like permissions and, restricting like who can modify what. There's some things, that aren't necessarily reflected in data model. For example, being able to apply forces to users, like you have like, like a gun and you shoot them and it kind of bonks them away. So there's going to be another thing where certain systems that are gonna be like, like you need this kind of permission to be able to like, do this thing. Like for example, I forced a user. So we could like, like you could, for example, say, I don't want, to get bonked like by random, gadgets, unless, for example, it's, from like it's been spawned by a friend or it's being held by a friend. So those are going to provide like, additional kind of granularity. Another part of the hard permissions is also going to be throttling systems. So like, for example, limiting how much you can actually bring into the data model, both in terms of, components, slots, but also in assets. So for example, you're going to have limit on how much geometry you can bring in. So if you try to spawn something that is like, 10 million triangles, it's not going to load it. Like you'll be able to like set limits. And it's always going to be, up to the host. So like if you want to host a session and you want people like, share like their complex 3D scans, you can do that. But also if you want a session that's, friendly to like weaker performance hardware and kind of want it more chill, you can, lower those like restrictions. So there's kind of like, combined systems that are going to provide. Oh, one more thing is also going to help is type filtering. So you can, for example, forbid certain types of components being introduced into the world like completely. So yes, like there's gonna be a lot more kind of permissions that we want to like add in the future to kind of like give people more control, how the sessions are run and how they kind of like operate. And the last question is from Carson. What does Boolean user override do? And actually I'm kind of prepared for this one because like I opened my Visual Studio so I can get my keyboard and I look at a component. Let's see. Boolean override. Let's see what it.
But there's nothing in there.
It's empty. Yeah, it does nothing.
Why is it? It does actually nothing.
It literally does nothing. I think it's like a stub of something that was meant to be added and it got abandoned like a while back. There's Boolean user override gather. So yeah, I don't actually remember what this was meant to do. But like right now it's a stub and we should probably just remove it since it does nothing. So yeah, that's the answer.
There's your answer. It
There's your
does
answer.
nothing.
It does nothing at all. We'll probably just remove it. I would do it right now, but I don't. I have to sync up my release notes and everything, so... Oh, actually I'm on a branch anyway, so never mind. I'm not gonna touch it right now. But you can make a GitHub issue, ask us, to remove it. And we'll remove it. So yeah, that's actually all of the questions from Discord, so... That's those sorted out, which means we can get, to the questions, you can enter the questions from the chat. So, Emergency Temporal Shift is asking, everyone likes to talk about Visual Studio, but what Nasal Studio? Is that something like you just like, with cilia or something? Like, the hardware you can smell things? They'll make the Nasal Studio. Or maybe it's like... Yeah.
Give me Tactile Studio.
Tactile Studio. I mean, there's probably things like that, there's like Braille keyboards and stuff like for visually impaired people and such. But Nasal Studio, it's a... It may be kind of difficult for like latency because like it takes a bit for it to like for the smell to activate and then to register it. But imagine like you're compiling and the compilation fails and like it emits a foul smell. So it'll be
smoke smell.
Smoke, yeah, smoke, and then like it compiles well and it's gonna give like a fresh, nice scent. So it conditions you, to write good code.
Yeah, you gotta get rid of that code smell.
I mean, it's actually interesting because, like there's been studies which show that, like if you have a smell associated with a memory, that actually helps you remember it a lot better. So maybe, like, if you're, like, depending on which part of the code base you're in, it emits a different smell, and, like, that helps you, like, remember what's in the code base or something. I don't know.
Yeah.
I'm taking this question way too seriously.
We add one smell per component.
One smell. I mean, no, that would work. Like, we can recognize, like, I think humans can recognize about, like, 50,000 different smells.
Oh, wow.
something like that. There's a lot of unique smells, which is what makes it also difficult, to make hardware, because like you cannot just do like RGB like the way we do for our eyes.
Yeah, we can represent all possible smells a human can smell in a single short.
Oh yeah, we could do that. We just assign each one a different one.
Yeah.
Yeah. Well, the question is, does the intensity like matter though? Because like you need like more for that, because some smells, they might be composite of different chemicals and have like different varying amounts. So it might need more than that.
Better use an integer just to be safe.
Might need more. Yes, integer. Might need more than integer. It might need to be like a variable data structure, because it can have like composite of them. Big int. Anyways, next question's from Flamesovo. What are security and safety measures taking place about peer-peer and its insecurities? It kind of depends what kind of insecurities you have in mind. I don't actually like know what exactly. Like sometimes like people get like worried about stuff like IP addresses, but IP is generally like that's like how your computer communicates with the internet. So like whenever you load a web page, whenever like use any like things, your IP is like where the data is sent. So if you connect to somebody, they need to know like where to send the data back. Few things you can do about that one is like the easiest is use VPN. That's kind of generally like protects you on the internet if you want extra privacy. Because it kind of hides your IP behind another kind of computer, but of course that VPN will know your IP, so that can help in kind of in general, because like anytime like you do anything on the internet, like your IP is how the communication kind of happens, but also there's not super much people can generally do with it. Like mostly like they can get like a rough location, because the IP is kind of located in blocks, but on itself nowadays the IP, like unless you have like misconfigured like firewall and router or something, generally it's not gonna do super much harm. The other thing you could do is if you're connecting to sessions, you can like connect through the relays, although like it might take like some like latency degradation, because now it has to like go through another node. Or like prefer Steam networking sockets, which realize stuff like over the Valve network. But I'm not sure like if this is like what you kind of had in mind, because there's there's also other stuff like for example man in the middle attacks. If somebody's on your network and they kind of like get in the middle, if they kind of like spy on your traffic and stuff like that. One of the things, like, we actually kind of wanted to switch to the game networking sockets from Valve, because they do have generally better security. Like they support like protocol level kind of like encryption for all the data that's being transferred. But it's still like missing some of the core features, especially bandwidth estimation, which we need like for our use case. So we could like explore, like, since that's taking a while, we could explore adding encryption layer as well to like to LNL. But it kind of depends like what exactly you mean, because like I don't know what do you imagine under the word insecurities. Like if you do want to ask follow up, like you can specify a little bit more, give us some examples, and then we can give more specific answer. Do you have any more thoughts on that? What it could be meaning?
I mean, it's really hard to tell like what they mean by insecurity. I don't know, because there are a lot of insecurities with everything.
Yeah.
And so I'm not sure like what they would be referencing in particular.
Yeah. In general, like I recommend being like more specific with the questions, because like otherwise we have to kind of make assumptions on what you mean, and I don't know if that kind of answers it. They're asking insecurity of P2P by default. I don't really know like what do you mean by that.
Doesn't really narrow it down. You gotta be like, well, like what aspect of P2P is insecure? Like, what do you want to address with that?
Anyway, we're gonna get like 10 more questions and see like if there's like more follow up.
Yeah.
Let's see. So Xavier Sly is asking, I'm very much looking forward to this. I saw a video on YouTube explaining states in an object. Do you have an idea how long it will take for you to do that feature? I can assume they mean the audio system. I don't know, like, I generally like try not to like estimate because like it tends to be kind of wrong. There's like there's I always forget the name. I think it's Hofstadter's law. I don't know. I don't know the name. But essentially every project will take twice as long to complete, even if you take the account, like, you know, the law into account. So if you estimate something to be 2 weeks and we go, aha, this law says, you know, that it's gonna be twice as long, so I'm gonna double it to 4 weeks, it's gonna end up in 8 weeks. And if you, like, you know, say like, okay, I'm gonna use it again in 8 weeks, oh, it's 16 weeks. I can tell you, I'm pretty confident it's gonna be shorter than the particle system. Because there's not as much complexity there, there's not as much, like, you know, backwards compatibility, but also these things, they tend to sometimes they can get more complicated when you don't expect it, because it wasn't until I started digging into specifics of the Unity's particle system and all the conversion issues that I discovered like just like a sea of issues and weirdness that we had to deal with, and that made photon dust take, like, you know, longer than I originally thought it would. You know, just kind of dealing, you know, with all the kind of backwards compatibility and people putting like negative values into like scaling of particles, which made the old Unity system, you know, not just scale them but also apply weird offsets, and then, like, you know, having to replicate that, figure out what is actually happening, and then figuring out how to introduce new features to emulate that old behavior. So yeah, things can, like, you know, turn into rabbit holes, especially if you're dealing with backwards compatibility, but also there's a lot less because you don't have like as many possible combinations. The audio is relatively simple, you know, you have like the volume, which is basic, you know, have spatialization. The hardest part, I think, might be replicating the distance attenuation. So, like, you know, if depending on how far you are, but even that, like, I don't super expect it to be that complicated because the math seems straightforward. But like I said, like, things sometimes turn into rabbit holes when you don't expect them to. But even taking that into account, I think it's gonna be like way shorter than the particle system. Plus, I've already done kind of, you know, like, as I'm kind of finishing Photon Dust, I've already been doing, you know, a bunch of research into, like, you know, how Steam Audio, like, how to interface with it and so on. I've tested, like, you know, Cyro, he's helped with a big chunk of it too, with, like, you know, replicating the reverb, and like I think I spent something like 2 weeks figuring out, like, you know, the presets, so like we can kind of, you know, upgrade them. And that's, like, you know, something that I would normally do. That's, like, you know, part of the work I did with Photon Dust, you know, is just figuring out how to replicate the old behaviors. And Cyro has, like, you know, done that kind of in parallel while I was still working on Photon Dust. And he's done, you know, that like work, so that's gonna help speed it up as well.
Jeez, so, man, that was rough. I basically I listened to some music, but I had a clip that I played where it was like, this is a test so that I can see how the reverb sounds. And then I listened to that clip probably over like 200 times, trying to make it sound the same.
We appreciate I appreciate your sacrifice, because otherwise I would have had to do something like that. So this is the benefit of having like more people on the team. You can just be like, you deal with it now, it's your problem.
You deal with the horrible thing.
You deal with the horrible thing. But yeah, like given that and given, you know, the other things, I think it's gonna be faster than the particle system. That's as much how I'm, like, you know, willing to say right now. Check the Fox author is asking, I'm probably gonna pass out soon. Is there a way to write butterflies while asleep plant? Make it up. You'd probably get a funny answer, I don't know. I mean, like, you know, I feel like it's almost a theme, because, like, you know, we're taking all the joking answers, like joking questions, too seriously. But I actually I had a dream that I remember vividly, where I was in Resonite, and in the dream, like we somehow made super cool materials. Like they look super, like they look otherworldly. Like they were some of the coolest materials, and in the dream, I knew that it was a dream, and I was like, I can't see this. Like I want to look at these materials when I'm awake. And then I was like, oh, I have an ingenious idea. I open my inventory, I save them in the dream, and I was like, they're gonna sync to the cloud. Once I wake up, I'll just spawn them and look at them when I'm awake. And that made complete sense in the dream. And then I
Yeah.
woke up, but I was like, that's not how it works.
That's
But
so.
but it is kind of interesting, like once we get like stuff like neural interfaces and stuff like that, I'm actually kind of like it's one of the things I'm super curious, like because there's been some research where like they put like stuff into people's like brains, like electrodes, and they would show them images, and they would actually decode from their brain what they're seeing, and it's very rough, like it's just very very rough image, but once that kind of technology develops enough so we can get pretty clear image of what the person is seeing, I want to see what people see when they're dreaming, because I think it's gonna be really cool. And it kind of like like I wonder eventually, this is like way 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 in the future, once we have the technology, if it opens up like applications that can actually run when they're dreaming, like if it's gonna open a whole new like industry of things, like where it actually reminds of like that Futurama bit, like where they get adverts in the brain, like when they're in their dreams when they're sleeping, which is kind of like probably wouldn't want that. But imagine something like like collaborative dreaming, like you're in a session and there's a person and they're just dreaming and they're like and you can interact with them in the dream. It would be interesting. I don't know. It's the future. It might be interesting in the future. In the future. But yeah, like that's a serious answer to the non-serious question. The next question is from actually I don't know how to pronounce the name. Diami. Will cloud spawning eventually be reworked? Well, cloud spawning is actually one of those things that is not officially supported, and we tell you this is not officially supported. We do plan to provide like cloud spawning eventually as an official thing, but it is like one of those things that it's not like official feature right now. And it actually did break recently, and it broke while trying to fix another bug, and we ended up like fixing that in this case because it was kind of trivial to do. But it's one of the reasons like we give people warnings. Like we can literally be fixing unrelated bug, and it changes behavior of some quirk you're relying on, and like now your thing breaks because like the thing you're using is no actual feature, and this kind of why we give that warning. But yes, we will eventually have like proper cloud spawning mechanism. The main thing is like making sure it's like properly secure, it can be controlled well, it's like well designed, and it's designed in a way that we can support it like long term. So next question is from Grady K. I recently had a moment where I thought component didn't exist, but it was just uncategorized instead of where it probably should have gone bit. Is there plans to go through categorized components and perflux nodes and move the ones that should be elsewhere to the right place? We don't have any specific plans, like they're just gonna do that. Well, actually, we do want to reorganize the components in the future in general, because there's like, for example, there's a lot of stuff in transform that like probably shouldn't be there just because it kind of got thrown in, and like early on with those components being added, like we didn't think super much about categorization. The problem is when we change categorization now, like people get upset because it breaks their muscle memory. So what our plan is, we gonna do the reorganization once we rework the component selection UI and include official search functionality. That way, you don't need to actually even know where it is. You're just gonna like type the name of the component, easy access. That kind of gets around the whole muscle memory thing, and we can like, that kind of frees up our hands to just do the reorganization. So it might actually get reorganized with that. But if you find some components in the uncategorized, and you feel like it should be in the categorized category, just make a GitHub issue about it. It doesn't need to be long, just be like, this component, should it be categorized? We look at it, it'll be like, okay, it should be categorized. It takes like a minute or two to do so. Like you can kind of do it, we can kind of do it on demand for specific components. Going through all of them, that will take a while. Like we might also like, when we do it, we might also like, just do a thing where we kind of export all the components into like a spreadsheet, and we kind of ask, community help, like how we categorize it and so on. We actually like did that with the protoflex nodes, where we kind of like, had the community like discuss like how do you actually like these to be categorized, and that's how we have the current protoflex categorization. The next ones. Carson Coder, do you plan adding protoflex nodes for permissions, granting your working perms when hard permissions come? Probably yes. Like once the hard permissions are in, one of the things the hard permissions also do is sort of track ownership of things. So if if you use nodes like that, the main thing you need to make sure is that somebody kind of just bring those nodes, get like the host to spawn them, and just grant themselves admin permissions. So, but the hard permissions are meant to kind of resolve that kind of issue where they know where something kind of came from, and there's gonna be restrictions on what context those nodes can actually run in. So like if you if they're in the world, you have like some logic that grants people permissions. You can you can like you can kind of be sure like that like only the ones that like were spawned by the host and maybe they were part of the world are actually able to change those permissions, and all the other ones will not work. There's something that's somewhat close to it right now, which is the custom user joiner, because the custom user joiner can actually assign the person a role permission on the spawn. And the way that one is made, so nobody can just bring it in, you actually have to assign it as the secure one, and only the host can do that. So there's like a little bit of like, a little bit also like, testing waters of that kind of mechanism, where, there's something that is still part of the shared world, but like, you cannot just bring your own and just grant somebody else, like or grant yourself, like you spawn an object, you leave the session, you join it again, and it like takes over and gives you admin permissions. Like you cannot really do that. But the hard permissions, they will provide like a more general kind of mechanism to control who can modify which parts of the data model, because right now it's like done in some specific cases, and it can still be done on a case-by-case basis. So having a framework to do that is going to simplify a lot of things and also be more robust overall. Next questions. Daima is asking, is there any plans on having avatars and other assets load up on the background from a buffer rather than all at once? Simulator to however handles the avatar loader. They actually load in the background. So there's one of these kind of like misconceptions that is like around. Like whenever you load assets, all of that loading, it actually happens, on background threads. All the fetching, like what essentially happens is the data model, it makes a request. It's like, I want this asset. And then, asset system takes over, and all the downloading, all the loading of the asset, it happens in background threads. And then it like, sends the data to be loaded to the GPU that does need to be synchronized to the main thread. For textures right now that will do time slicing, and it's like, it's a limitation of like, the DirectX 11 API, because it doesn't support uploading from a background thread. It needs to be done from a main thread, unfortunately. But majority of it is like, already happening on background threads. There's one of the issues, because like we are doing the loading ourselves. because the loading is actually heavily multi-threaded, it tends to allocate like, a lot of memory because it tries to utilize, your CPU cores, but it actually triggers the garbage collector in Unity, which causes, some of the freezes, and it kind of, hurts because like the garbage collector, it has to pause the entire application. And it's one of the reasons, why we want to move to .NET 9, because it has like way better garbage collector. The background threads will not impact the foreground thread as much as, as can happen. With stuff like VRShell, because they are using, at least I'm pretty sure they're like using Unity's functionality. Unity is running that outside of like, C# in their own code, so that, doesn't trigger that. But because we are pretty much an engine, like our own engine, within a game engine, we kind of hit the limitations of the runtime. And that's, why I kind of want to move it out of there. One thing that's gonna help a little bit is like time slicing of the mesh uploads, because right now that doesn't happen. So the meshes specifically, they get loaded at once. And that was a little bit trickier as well, because like Unity doesn't provide like good APIs for doing that. Like it doesn't provide it even for textures. We kind of had to design a system that's just, kind of hooks into Unity, and like we essentially implement our own texture uploading to the GPU. Which is a fair bit of work, but it kind of helps, so you don't freeze up as much. And kind of used to do similar thing for meshes, but there's a little bit more trickier there. It might happen as part of the split, because I might need to change, how the data actually gets transferred over. But for the most part, it already does happen on background threads. And some of the kind of freezes like you're feeling, it's actually coming from other parts, like, the runtime. The runtime kind of like, not actually handling the parallelization as much. Which is also a reason, like, why we tell people, like, we oftentimes, like, notice people have this association that like just make everything multi-threaded. It's gonna make everything like better. It's gonna make everything faster, and people think of it as like a silver bullet that's gonna solve all the performance problems. But it's really not. Like in some cases, actually might end up being detrimental, because if you have like limitations of the runtime. Once we switch to .NET 9, it actually makes it way better, because the runtime is kind of designed for that a lot better, to handle, all those background threads, because with .NET 9, all the background threads, they also get, their own chunk of memory to work with, so they don't even need to, like, block other threads, versus with the Unity one, there's just, like, one shared one, so if, like, one thread, like, does a lot of memory allocations, that's gonna make the garbage collector stop all of the threads, like, in every single case.
Yeah, the .NET garbage collector is, like, meant to work, like,
On servers.
It's concurrent, isn't it?
Yes.
Yeah.
It's concurrent, it's compacting, it's doing a lot of things. It's generational, that's the important thing. Because there's actually, if I grab a brush, I don't know if this is going to be too small, it's going to be just a little sketch, but like, say like this is your, this is your memory. And, and you'll allocate, something here, and something here, something here, and then like it decides, okay, I'm gonna free up some memory, and say like this is, say 16 gigs of memory allocated. It's quite a bit, but let's imagine it's 16 gigs. And the garbage collector is like, I need to, oh, what happened to my controller? Oh, there we go. And needs to free some memory. It has to scan everything. Even like if this is fixed, this is fixed, this is fixed, this is fixed, and maybe this is fixed, it scans all the 16 gigabytes pretty much to figure out, okay, there's a little bit space here and there's a little bit space here to free up. What like the modern generational garbage collectors do, they actually have like tiny bit of memory. It's usually something like 4 gigabytes, where all the new allocations happen, or at least most of them. Then there's like bigger chunk of memory where there's like more long-lived allocations, and there's like another one for really big things. So if something really big, it goes here. Most allocations will go here. And there's like interesting thing with like the way most applications are written, most allocations are very temporary. So whenever it needs to free up more memory, it actually just looks at this tiny piece of memory it frees that up. Anything that it cannot free, it's gonna move over here to like more long-term memory. And now instead of scanning, 16 gigabytes, it's scanned 4 megabytes, which is, orders of magnitude faster. And it only cleans like this one, every now and then anything that's like really big, it puts it into special blocks so it can handle it even more efficiently. So like this table is gonna have like smaller bits, and then very large allocations are gonna go into their separate piece. And that helps a lot for the garbage collector to just have like way better performance, because it can free up like this tiny chunk of memory most of the time. It doesn't need to collect this one as much. It's also gonna, it's gonna, like, whenever it's dying to free, it can actually kind of do that without stopping the application. The garbage collector is in Unity, it needs to, like, the moment it starts trying to scan the memory, it essentially stops everything. It pauses your process to do scanning, and it kind of, like, to prevent like long spikes most of the time, it tries to like do that, like where it like pauses it every frame for a bit, which takes a lot of like CPU time as well. So like, a bunch of like CPU time is like being spent just by the garbage collector just scanning the memory. So it's gonna scan a bit, resume application, scans another bit, pauses, like, lets the application run, scans another bit, lets the application run, scans another bit, and it just kind of keeps doing that. But if it doesn't have enough memory, it's gonna pause it and do a whole scan. With this one, the more modern, concurrent garbage collectors, they actually can scan they do most of their work while the application is still running. So the application's running, and then usually pauses it for much smaller amount to just do, whatever work requires the application to be paused. And that also helps a lot, for things to just perform like way better.
Yeah, there is to illustrate this difference, I was working with some like test program that was I think I mentioned this to you, is reading data over USB, and it was written in C#. And since it's a test program, it's not written all that efficiently. And so it was allocating 40,000 a byte array of 40,000 bytes every 60 times a second, I should say.
Oh my.
And it was doing that, and the program like CPU usage was at like 0.1% while it was doing it.
Yeah.
And it was just like, wow.
It was very efficient.
Man, it was like throwing like flower petals at my feet and like putting luau's around my neck. You do that in mono, you get stabbed.
You die.
You die.
I remember like one of the things, like, with garbage collectors, Java also tends to have really good garbage collectors. And we would be actually playing Minecraft, and I look, and it's like allocating several like dozens of megabytes per second, and it's just going whoop, 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 whoop. It's just constantly like cleaning up, like, and you cannot really even tell. With Unity, like, you can be allocating, if you're allocating half a megabyte a second, constantly, you're gonna be dying. I had to like spend time, just optimizing things to get it, under like just a few dozen kilobytes per second. And that was really painful. It cost a lot of time, but it's just, how limited like the garbage collector is. So I can't wait, I can't wait until we like we're better runtime, because like it's kind of gonna free us, from a lot of these things. Next question's from Ages Wolf, actually. Hello, Ages. What if you dream Resonite again and you check your inventory and it's still there? Does the dream inventory sync in there? I mean, it might not happen, maybe.
The dream cloud.
The dream cloud. Eventually, if we have a like brain neural technology, we'll make it so you can save stuff from the dreams. Yeah. If that's ever possible. The next question's from Troyborg. I hope the search feature provides multiple relevant results. For example, if I search conditional or use the symbol question mark colon, it should return the same information since both refer to the same concept in game. This way, I can still find what I'm looking for, even if I don't know the exact term. Yeah, we'll probably want to like, index a bunch of things. Like if you have like, even information like description of the components and stuff like that, we want to like, include that. So like you're very likely to get whatever result, is relevant. Usually, like, it just matters, like when you use like a library for like do full text searching, you can add whatever data you want for the index, and that indexes that, and the search is based on that. It also supports like stuff like fuzzy search and so on. So it's that kind of helps it behave like better. Next question is from Ozzy. I could be wrong this information, but from what I understand, running headless Froox engine is running on .NET 9. It doesn't compile with .NET 9. Compiling with a new runtime means even greater performance gains, right? Even if it is impossible, the client is running though. So the headless itself actually is like so. Not to answer this one. The headless project itself is compiled with .NET 9. That's how it kind of runs on it. But it includes libraries. Most of the Froox engine is a library that is not compiled with the .NET 9 framework, but the .NET 9 is actually compatible. So like if you're using libraries that were made for .NET framework, most of it will work, and it's using .NET framework specific stuff. And it doesn't actually matter much because like during the compilation process, usually there's very little optimizations that are being done. Most of the optimizations happen in the JIT compiler, which means when you run it with .NET 9, it's like all that code, even though it was compiled for .NET framework, is actually being compiled by the JIT compiler for .NET 9, so you're getting majority of the performance benefits. It was kind of designed this way because it essentially means, you can compile your application once, and if you run it later, you can run it with a newer version of .NET Framework, or now new version with .NET, and you get all of its benefits because, it has backwards compatibility, but also all the future improvements, and all the heavy optimizations happen, at the JIT compilation time, which happens, after you start up the application, start using the code. So I don't expect much to improve just by the compiling, by targeting for .NET 9. But where it'll improve is because we'll be able to use new features from .NET 9. Like I mentioned earlier, like for example, doing vector intrinsics. We can optimize, a lot of our math, using like really fancy code and using other kind of constructs and libraries. That are just written to utilize some of the new features of the language that we cannot use right now to run better. But that does require manual work. Like it's not just, you change a flag. Granny is asking, when messing with a string type, in components is referred to as a value, but per flag is referred to as an object, which can cause confusion over which components flags knows to use. Are there plans to fix this inconsistency? No, it's not something that's fixable. It's essentially like in the Resonite, anything like in the data model. You essentially like the main problem is you essentially have two kind of different systems, which each use words in different context, and those systems they're just gonna be different because they're different systems. In the data model, value, like anything that's a value, it's sort of like this atomic unit of data, like a number, like a character, a vector, a matrix, a string. It's sort of like a data primitive that's not really, divisible in itself. It's sort of like its own unit of primitive information that's supported in the data model. And that's what data model considers a value. And then, then it also has references. References is like, what references kind of objects within the data model. So that's another term. You also have delegates. Delegates are kind of similar to references, but it's basically reference kind of methods, which is something, like a function that you can call. So those are some of kind of primitives. For protoflags, the value and object is actually based around the C# runtime, because in C# runtime you have you have two major data types. You have structs and you have classes. Structs, they're sort of just raw bundles of data that can be oftentimes allocated on the stack. You can also put them into the heap, but oftentimes they'll be on the stack, and it's just it's like it's just like a bunch of data, you know, that's like in a chunk of memory. Classes, you know, you instantiate objects, they always go on the heap, and you know, they can oftentimes also be like, you know, like variable kind of size and stuff like that. And you kind of need to like, you know, like you don't actually store them directly. You usually store like references to them. You kind of you point like, you know, where they are into memory. And those are also like ones that undergo, you know, garbage collection. Like once you kind of like, you know, lose all the references to one, it's just gonna free it up. And in C#, strings, they're classes, which means like, you know, it treats it as an object. It cannot treat it as a value because it cannot be stored on the stack because it has like, you know, varying length. Usually value types, they're fixed size. And like the size is kind of known at the compilation time. So it's not something that can unfortunately be fixed. It's just like, you know, it's sort of like overloading terminology. Where it's like, you know, like it's similar term, but it like means different things in different contexts. One thing that I think will help with that is like we want to improve the selector. So most of the time you don't have to like pick which one you want, and Perflex is gonna be like you just plug something in, and it just figures it out for you. Like, you know, like you don't have to think about it. That way, like you might not even like, you know, deal with values / object like at all. And I think that's probably the best way to kind of approach this.
Yeah, strings in like C# are kind of, to me they've always it's one of those things where like I understand how it works, but like when I think about it, it kind of seems like it's a little strange because they're reference types, but like in like when you pass them around like a data model, you know, you can treat them like a value almost.
Yeah. Well, you kind of like in the data model, it's just, you know, like the primitives are going to consider like immutable. So like, you know, if you store it somewhere, you overwrite the whole thing. You cannot like, you know,
Yeah.
kind of mutate it in place. So that's like, you know, one of the aspects to it. And it's sort of like, you know, a building block that you can like, you know, that is like serializable and so on. And the big difference, like, you know, why in the runtime, like for example, if like an integer's 32 bits, it's always going to be 32 bits. You know, it's a fixed size. You know, float is 32 bits, double is going to be 64 bits. If you have like, you know, float 4, that's, you know, 128 bits because, you know, 32 times 4. They have like predictable size. But if you think about strings, a string can be, you know, it can be empty. You know, which means like it actually has like 0 bytes for the actual string data. There's gonna be a little bit data, you know, just to specify the length. Or you can have string that's, you know, 10 letters, you know, 10 characters. Or you can have like one that's 100. Or you can have like one that's 10,000. Or you can have like one that's like a million. It can have like very, very widely changing, you know, length. And it's like, you know, why cannot really store them on a, you know, store them like that because they kind of vary in size. So it's just kind of like, you know, it's like the terms are essentially not really related to each other between these two systems, and it is a bit confusing, but sometimes it kind of just happens because you have like overlapping terminologies or overlapping words. Next question is, I got a question from last office hours you said to ask again. The avatar haptic source manager, that's a mouthful, directly asks for haptic volume active states, however active states for haptics doesn't usually disable them, only collider enable status is as intended. Well, this is why I have the keyboard and I can like look at the code now. So let me grab my keyboard. I actually will probably need to read the question again. Let me see. So I got my keyboard, I got my Visual Studio. Let's see. So the question, actually I need to look at it. Avatar haptic source manager. So I'm gonna look at that. Let's see. Avatar haptic source manager. So this is like one of the things I actually do a lot because there's so much code. There's so much code, you know, for Resonite. Like I like, and if it were like a word, like majority of it, I don't remember a lot of it because there's just so much. But one of the really good skills, like, you can have, and like when you write your code, is make it easy to navigate. So you can, figure out like what you need. So we have this component. It has haptic volume active states, and it looks like it's just like changing if they should be active. So the question is, the actor doesn't actually disable them on the collider and both status as is intended. So okay, so this component disables the active states. So this component does, it essentially just disables them if you're too far away. So whatever you drive with this component, it's gonna be active. It's gonna be active when it's not under your local user, which means like you're never gonna have, you're not gonna trigger it on haptics. That's actually, I think this is one of the reasons you cannot touch yourself in Resonite, not without another copy of yourself. And when your distance is less than 4 meters. So it just looks like it kind of, I think this is like an optimization thing, like where I've added it, like, so like you don't have to process all of the colliders, they just kind of get disabled, like, when the user's too far away. So this probably might need like some more refined logic for this, because I don't know how it like works, when you're really big and stuff like that. And it measures the size, to the user's head. So yeah, like it makes them locally active only when the user's close enough. There's also haptic volume active states. But yeah, it doesn't really interact with anything else. So yeah, it's yeah, so like this is only, like they're only gonna be locally disabled for you if the user is far enough away. So I kind of hope like this kind of helps with whatever you're sorting out. There we go. Check the code. The code is the code is the documentation. Oh yeah, and Gal is asking a question for the audience. Have you switched to Stripe yet? Garly like did like majority of like the Stripe implementation for us, and we've had like people switching to it. There's actually a new endpoint too, so we can see how many people are on it. Let's see. API funding stats. We've got funding stats. And if I look at the Stripe, we currently have, we're almost at 3,000. There's 2,980 USD per month, with 184 active supporters. While Patreon, that's currently 2,195 active supporters. So that's what, like, around almost 10%, like something like 8%, just doing like a little head math. But yeah, people have been switching to it, like we're very grateful, because whatever reasons, like even if you're supporting us on Patreon, we kind of ask, consider switching to Stripe instead, because with Patreon, for like every dollar that you pay, roughly on average 15% goes to Patreon. Versus with Stripe, only 5% goes to Stripe, which means we get 10% more, from your payment, which if everybody, like if every single person who's currently on Patreon switched, we would get like, something like a few $1,000s more every month. For a company of our size, and like very kind of tight budget, that can help a lot, because, now we can kind of invest it into other things. To help this project grow. So for everyone like, who switched, like, thank you so much. Like it helps us a lot. For everyone like, who's still like on Patreon, like consider switching. I know, like, so there's a bunch of people who are kind of like waiting to sync up their things, so like they switch around the time where their Patreon would renew. Um, so I think like we'll probably kind of see it like, kind of like change over time. I've also seen some people like kind of waiting until after MMC because they don't want to like, mess with stuff. So like, that's fair too. There's a bit of a grace period. So like when you cancel Patreon, there's like, you get like few extra, like whatever you already paid for like that month, that's gonna, finish. So like when you cancel, you're not gonna lose your benefits, right away. You already, you essentially pay for the benefits for the upcoming month, and there's like a few days grace period, for like any kind of billing issues or switches and so on. But yeah, thank you everyone, like, who switched so far, and if you're planning to switch, thank you as well. Ozzy's asking, I believe it is a plan to be able to add more grabbers, but is there also a plan to allow extra grabbers to be controlled via Flux? For example, being able to grab by impulses or the like. Yeah, I was kind of like to like expand it a bit more. There's actually one thing I want to add is like a grab, like, so you can like have like just more grabbers in general. Like there's sort of like bits, the code is kind of prepared for it a bit, and then like, having like some integrations. Like one that would be fun is like, for the mouth tracking, so you can be like hump and grab something, with your mouth. Be like hump. Some people do that, like by moving one of their grabbers. Other ones having, one for your feet. And I keep like making this joke, which isn't actually a joke because I do it. If anybody makes a toe tracking hardware, like if you make something, so you can curl your toes, and I get my hands on the dev kit, I'm gonna add native support. 2, I'll make it work with the grabbing system, so you can, grab things with your feet. So if you wanna if you want, like, that to get like a priority bump, like make some hardware for it and just send me a dev kit and it'll happen. It's gonna be the food grabbing update.
You mean when you get your feet on a dev kit, Godly
Yeah.
says.
Yeah, when I get my feet on the dev kit. I'm just saying. I'll do it.
All right, community, you know what to do.
Yes. I mean, you could like do one like relatively like easily, like I think like, so like if you have your food, you could like say like, this is your food, which is a horrible drawing. Actually, I'm gonna do better drawing. So like a foot, and then have like your toe. So like, like you can like rotate your toes. So I've wondered like if like an easy way, like I wonder if this would work decently well, is essentially you get 2 IMO units, which essentially, just like accelerometer, gyro, and magnetometer. So you can like, get rotation, and you make some kind of contraption like where one piece is here, the other piece is here. And then you just get like, the relative difference between the angle. Because like if the whole food rotates, like these two kind of stay the same. And if the toes rotate relative to it, then you should be able to get that information. Get the difference between the angles. The only thing is, if these two, because they tend to drift, so like I wonder if they're not gonna drift apart, but like maybe with the magnetometer it can help, and maybe, the accelerometer, because you're gonna have, gravity that's the same on both, so you could maybe use that to compensate like pretty well. And it could be like a relatively cheap solution, to do something like that.
Yeah,
but just throwing that out there.
I wonder if there've got to be like chips that can determine, like let's say you had a magnet relative to a thing, and you rotate one of the objects. There's got to be some kind of component that can tell the relative direction of the magnet, based on that thing's rotation.
I was like stuff. I was like Hall sensors too. I don't know, like if it'd be good for this.
Because like what I'm thinking, right, is if you had one of those devices, you could determine a magnet's like relative direction to it. So you'd only need one device. You just need a magnet like on your toe, and then you need that chip on your foot. And then when you move your toe, or no, you'd put the chip on your toe. Sorry, put the chip on your toe. You put the magnet on your foot, and then you could tell the relative direction of the magnet relative to the chip.
I don't like if like you get like if you get it from that, because like I don't know if you can measure directionality of like, you know, magnetic field like that easily. Because like if you like think about it, so say like this is one on your toe and there's like your like sensor. You can think of the magnetic force, you know, it's like a force. It's gonna be, you know, it pulls it. But like you're not getting the direction, you're getting the strength, you know, so it could be like if it's here, it's still exerting the same strength on this, unless this can, you know, somehow detect the directionality. But like I don't think I've heard of anything that could, because like I feel like if you needed to do that, like, you know, inside of it, like you would need like multiple sensors, and then like, you know, if a like magnet here, it's gonna be pulling these, you know, this way, this magnitude, and if this is here, then, you know, this is further away from this one, so this is gonna be weaker force, and this one's gonna be stronger, and from the difference between these two, you will be able to determine the direction.
Yeah.
But, you know, this is gonna be really small, so like the difference is gonna be really small, and I don't know if you'd get it like accurate enough. There's like stuff like, you know, like flex sensors, so you can also like, you know, you like have a sensor and it can detect when it like, you know, flexes too. The other part, like, you know, would be also the drift, because like if you have the magnet and it kind of changes over time, I don't think that one has a good way of like, you know, self-compensating. And that's kind of like, you know, why I was thinking like the IMU might be the best way to go about it, because you have like, you know, they're all cheap, like two cost like nothing, like, you know, it's like, what, like it's gonna be like $2 instead of one, maybe. for the parts. So like I don't think like having two is like, you know, big issue. And what you get with each, you know, you get the orientation from the gyro, which can drift, but also you get the accelerometer, which is always gonna be, you know, when it's still, is gonna be pulling downwards because of gravity. So it's gonna measure that, and you can use that to make sure they are aligned. And you also have magnetometer, which is aligned, you know, with Earth's, you know, magnetic sphere, so you can use that to also provide a source of calibration, like to provide correction for the drift. I think we're getting deep into foot tracking, the toe tracking specifically. It's also like, you know, some people like solutions like put like mount lead motion on the shin or something, but I feel like that's kind of an overkill, because, you know, your fingers have way more dexterity than your toes do, so I don't think you need as much for toes. Just make like a toe tracking sock you put on, and, you know, now you have toe tracking and you can grab things.
Yeah, that would be kind of cool, actually. I bet that would be possible to put in a sock.
Yeah, just something you put on. Or maybe just, you know, so it's small, you put it on and you can put sock on top of it.
All right, we need to put light.
This is one of those things, if I had time, I would like, you know, do this. I would do this myself, but the problem is I don't have time.
Same.
I would provide an integration too. Anyway,
well, it seems like we're mostly out of questions. I think those were. Yeah.
I'm just kind of like, well, I'm just, you know, going into these like silly ones, because we still got like, actually, it changed the formatting. Why is my clock the US time? I think we got 40 minutes left.
Yeah, we got about 40 minutes left.
There we go. Yeah, if you got like any more questions, you know, feel free to ask. But yeah, we pretty much asked the Aussie one. It's kind of started this whole thing with the Gerber. Then there's one, the Jip force, I think I would explain with magnet forces is roughly how effect works. Yeah, like, as far as I understand it, like, Hall effect doesn't give you directionality. Like, you know, you're gonna get like intensity, which means if you want directionality, you need to measure intensity at different points and use that to triangulate direction. But, you know, if you want to keep it small, that can be difficult. But yeah, it kind of covers the questions. There we go. Space Spec is saying, I have sudden urge to make smart shoes now with 5 more IMUs. do
Yeah.
it.
There actually is a thing that I've been thinking about in terms of, because you know how a lot of people with like their standalone headsets, they still want to use like their lighthouse trackers so they can have full body, but obviously the coordinate systems don't line up.
Yeah.
And so they have to do this whole song and dance with like a tracker and like move it in like figure eights around the room and
Yes.
wiggle it around to kind of align the coordinate systems using some algebra. And, that's prone to some drift over time. But like, I thought of something that I'm surprised nobody's done yet, because I think it could work. Is if you were to say like stick a tracker to your headset, right?
Yeah.
Um, like you just Velcro it there, tape it there, glue it there, whatever, and you assume that that tracker is never going to move from that spot. If you then do that whole, song and dance once to get the relative offset of that tracker to the headset, since you know that tracker is offset from the headset permanently now, why not just use that to align the coordinate systems for the rest of,
No.
the rest
People
of the
do
time?
that.
Well, no. They don't though,
Really?
because
I've actually talked with
what they,
several people who do
no, no,
that.
no,
Like
no,
they
no, no,
actually
no,
put like tracker on their headset
no, no, no,
and
no,
they just corrects the
no.
drift.
Mm-mm. So what that's doing is that's performing that calibration continuously. It's
Yeah.
not using the offset. It keeps calibrating. Like it keeps doing it over and over and over
Yeah.
and over again and while you're moving, but it doesn't actually use the static offset. So if you sit still for a while, it's going to get less and less accurate because it's taking samples from where you're sitting. And if you then walk around your room, it's not going to be accurate anymore.
Oh.
So it's a different it's the same idea, but it's a different methodology where instead of just you continuous, like you do it once and then it drifts and you do it again and then it drifts, it keeps doing that calibration as you move around your room to try and keep it in place and like average it out over time. But like if you sit still, it's going to take samples and it's going to get less accurate because it's not sampling your room anymore.
I'm not sure. Like, I swear I talked with people like who recently were doing that because like they were like, you can either do this to calibrate it, but then it drifts, or you just keep the tracker on the headset and it stays in place.
Yes,
But
because when they have the tracker on the headset, that calibration, it's not using the static offset. It's keeping that it keeps doing more and more and more calibration.
yeah,
So it's as if you are like calibrating the thing over and over and over again, but it's automatic.
yeah.
With what I'm saying is you perform that calculation once and then you know the static offset from the tracker to the headset. And then you can just use that offset to align the coordinate systems rather than having to calibrate continuously.
I don't really understand. Like that's pretty much like what I'm describing. It's like because like if you have the static offset, like why does it matter? Because like you're still using the tracker to calibrate the system. Like you still need to know like where the two tracking systems are relative to each other.
Yes, but once you have the offset, you know that offset to the headset. You can use that to align the coordinate systems without having to calibrate anymore. What
How?
they're
But how do you align them? Like when you don't calibrate?
You would do the calibration once to get their relative position, and then you know it forever since the headset would
But
be glued.
but that's the problem. Is like this. It's the tracking systems that drift from each other. Like it's
But
not
if
like
you
the tracker relative to the headset. It's like the whole tracking space is like accumulating errors. So you do need to kind of keep calibrating them to each other.
I don't know. I feel like this could work.
And
Maybe I'm just not describing it.
yeah, I'll probably think it's like say like a diagram or something. What do you mean? Or like look into like those projects and because I know like some of them like open source, so like you could like peruse and see. Uh,
Uh,
the next question is Platypus744. Hi, I was wondering if you could give a little walkthrough of the locomotion animation component. I love using it to add personality to my avatar, but little unsure of the effect on some sliders and their relation to each other. Also, I noticed there are colliders on bones, like hips and arms, and these are important to adjust any rest locomotion. Thank you for building a Resonite. And we could give a little... so do you actually have like a custom one on you, or... No?
I do have a custom one.
Do you?
Yes.
Okay. Let's see. I'm gonna switch the camera to smooth POV. Do you mind if I use you as a guinea pig?
Yeah, I don't mind.
So I'm gonna grab the development tool. Oop. Let's see. Gonna move this here. So let's open you up. Actually, where's your custom one?
It should be under. Hang on.
Oh wait, let's keep it on camera.
I apologize. Actually, there it is. Locomotion configuration.
There we go.
There we go.
So there's a few components, like you're gonna find, and every avatar should pretty much have this, is like metrics. So this is kind of, you know, sort of like just telling the system this is how, you know, for example, how far apart like the feet are. So I can, if I change this, that's gonna change the default stance. So if you like move a little bit, like the feet should go into a new stance.
Huh?
Yeah, just move around a bit. There you go. And you see, like now, stop now. You see, like now here kind of has like way wider stance, or you can like, you know, lower it. And now if you move around, like the feet are gonna be really close to each other. So you can kind of use that to like, you know, fine tune, you know, your avatar, and like where sort of the separation is for how things move. There's also like, you know, stuff like feet backwards offset. So like, you know, if the feet are, for example, too front or too back, you can change this. So if I'm gonna intentionally put a really big value so you can kind of see what it's doing. So if you move now, you see now his stance is actually, I push the feet backwards quite a bit, and I push them really far. If I put negative number there, that's gonna put him in front, so he's gonna be, you know, standing like that. And if I put 0, you know, it's like whatever the default is. Actually, it's gonna be like centered, and if it's not, then it's like default. You can change, you know, how far like the feet go front and back. This is kind of, you know, for the size of the foot, so it like properly tilts and so on. Usually you don't need to touch these as much, but you know, is there. Then there's hand animation metrics. That's, you know, similar thing, but for hands. So there's, for example, shoulder separation. You know, that's like how far the shoulders apart from each other. If I put them like further out, and if you move. Actually, I don't think this is doing super much. Shoulder height, that's like how high they are. Should be the hand offset, I think. So if I put this, yeah, there we go. So you see, like, for example, like if you want the hands to be like, you know, further apart, if your avatar is, you know, bigger, you can like do that. Move them back, and then like the meat of like, you know, the actual animation, how it works, that's the locomotion animation configuration. There's a bunch of categories because the system is like in multiple modes. One right now, Syra is standing, so like, you know, he's standing still. There's a bunch of properties for that. There's, you know, like, for example, threshold for the velocity. That's, you know, when it's the avatar to be considered to be standing still, and when it kind of transitions into different modes. It can be in air and it can be floating. Those are kind of different. When it's in air, it assumes that it's falling. So if you, for example, jump, like he's kind of in air, but floating is when you go like into stuff like no clip or fly, where you're not gonna be like moving upwards or falling. So those are two separate modes. So for example, for the floating, so stay floating, hand floating force. Like if I try to ramp that up, you see now the hands are kind of like moving a lot, and if you move a little bit, can you move like slow? Slower than that. You see, like I ramped it up, so like now they're like very springy because there's like a lot of force applying on them. And if I lower that, you see they sort of like become more sluggish and wobble like that. this kind of, you know, good way to kind of understand the system is, you know, just mess around with the values, see kind of like what happens. It's similar, you know, for the air, but like when the avatar is in air, it works a bit different. So can you go back into physical and say, I jump for me. See like how the hands kind of move. Okay, and if I say I ramp this up and now jump, you see like the hands are like doing less of this kind of like motion because there's a lot more kind of drag being applied to their movement. Like it's like drag is usually like, you know, how much it kind of resists movement, and the air force is how much. Like if I set it to 0 and I set the force to be really high and now jump. No, they're very jittery because like there's a lot of force. They're trying to like get like into whatever pose they want to be, and there's like very like pretty much now 0 resistance. So you know it's like one of the things. There's a bunch of like, you know, poses. That's essentially, you know, where the hand's gonna go. So here upwards pose, you have like there's upwards and downwards. So like when you're jumping, you know, there's the upwards phase and downwards phase, so depending, you know, which direction you're currently moving. So for example, for upwards pose, let's say I put this really high up and now you jump. You see like how they go, it kind of changes their behavior. If I change that, you know, say I actually put them sideways like this, now jump. You see how they kind of spread out because like I'm adjusting the X, which is the horizontal. You can also change like the Z is forward. So like it's gonna be front back. So like if you jump, like, you know, see like he puts his hands in front. If I look at it from side, you see like he puts them like this. And I go undo, keep jumping. And you see like now they don't go as much forward. So I'm kind of adjusting, you know, the pose where they should be during that kind of motion. So there's like a lot of kind of stuff. There's stuff like motion transfer. Motion transfer is, you know, when it moves around, is how much of the force from the movement applies, you know, to that body part. So say I move this up, and you see how they now like, you know, like in behind a lot, because like pretty much like it's almost like that, like they have like 100% inertia. They will not want to move with the body. If I set it to 0 and then we move, then actually the motion itself is, you know, not applying any kind of force on them. They kind of like, you know, they stay stationary relative to the body. And usually there's a little bit of motion transfer, but not all, because like when you move around, it applies a little bit of force, but you're also kind of, you know, holding the hand. There's a bunch of limits, like for example, if the feet are going too far and so on, you can kind of restrict, you know, how far they go. So like if I lower this, I think it's like one less visible. There's stuff, you know, like hand swaying, like there's usually when you're still. So if you stay still, there's the swing speed. If I increase that, like, you know, it's gonna go faster. The sort of like the idle movement. There's also like, you know, what happens to hands when you crouch. So like if you crouch, to actually change their position, and you know, there's the offset. So I can, for example, move it up. Oh, there's actually the center offset. That's kind of, you know, the direction based on which they position themselves. So if I do this one should be the offset. So see, I move them upwards. Or I can, you know, adjust the horizontal, so like it can be like I have a really big watermelon. And if you uncrouch, they go kind of, you know, back to the rest pose, and you crouch again, you know, they go to this pose.
That's kind of silly.
Yeah, you can kind of play with it. Like usually the best way, like, you know, to understand the system is like change the value a lot, watch what happens, and then, you know, tweak it to be like, you know, smaller. There's stuff that happens to the foot, like, you know, when you're in air. So for example, when you're like jumping, you know, and it's kind of similar to the hands pretty much, you know, it's like the air drag. So like if I set it to 0 and you jump and you move like while jumping, that's gonna, you know, the feet are kind of lagging behind. There's not much force applying to them. So you can kind of tweak how that behaves. Similar for like moving. There's also like, for the head movement. Like, for example, when you jump, the head like is gonna move a bit. So if I increase that and you jump, wait, is this head jump angle? I think there might be like a limit on that. Vertical force. Actually, I might need to increase that. Lower the drag. Try jumping. It's actually not doing as much. Oh, right. This is okay. Sorry, I changed the. So this is sort of like when you jump, like the head actually like also lags a bit, and because I set the drag to 0, now like there's nothing kind of stopping that motion. If I increase the drag, that's gonna that's gonna stop it. Like it's sort of like the force is still too strong.
There we go.
There we go. It binds quite a bit. A similar thing, you have the vertical transfer ratio, so like when you jump, like this kind of like the head doesn't want to move. I'm gonna lower this. This transfers all the motion. And it should be also like, there's maximum vertical offset, so if I set this really high in the jump, it's gonna be like boing, boing, boing. Minimal vertical offset also gonna...
Whoa.
You essentially, there's like sort of a clamp that happens on the head. If I override this and out of the range, I can make it real goofy. So hold on me.
Oh my God. Jesus.
Yeah. See, this happens when we have no drag.
I'm so excited for the big performance update. I'm so excited. I can't wait. Oh my goodness.
And you see, I've increased the force. The force is like the force is essentially what's trying to return it back to its normal position. So it's kind of like a spring. It's trying to like move it forward, and the stronger it is, the faster it goes. The problem is there's now nothing slowing down the force because the drag is 0. So if I increase the drag, that kind of dampens the motion. So spring. There's a bunch of other, when the head is floating, like what kind of force applies to it. There's like, swaying, like when the head just kind of looks around. So if I increase that, now you don't actually need to jump. For this one. And there's minimum speed, there's max speed, so I can like, can increase this.
I'm dancing.
You're dancing. Oh, and there's also like minimum and maximum speed, and there's like speed, which actually influences how fast like it moves between these two values. So like if I set this to low, like you see it goes slow for a while and then like goes fast and it's slow again. And if I like make it really high, then like each period is like way shorter. There's also like a bunch of stuff for fingers, how they're kind of curling, how they're kind of like moving around. There's like offsets being applied to them, so kind of got details. And then like the big meat of the things is something called gates. Gate is, it's sort of like a way your legs and your entire body moves depending on the speed you're kind of going at. And each gate, it has like a reference speed. There's gonna be, that's like the speed where it should be active, like fully active at. And you see there's like 0, that's essentially one, like when you're stationary. The next one is gonna be, let's see. Reference speed, it's like 1, that's usually like, slow walking. And then like, there's gonna be another one, like when you're running. And you can add like, usually there's these 3. There's like, the walking gait, and then there's the running gait. You can add more, and it essentially transitions all of these parameters smoothly transition as change your moving speed. So if you're going slow, like if you're just gonna walk around, your body moves a bit different versus when you run around, where it kind of does like your hands kind of start swinging more and such. And for each gate, there's a bunch of kind of options. let's see where the beginning is. So, like, we have the reference speed. There's also something called min opposing progress. And what that means, that's essentially when your feet are moving, that indicates when the other foot is allowed to start moving depending on what the other foot is doing. If it's at full 1, your opposing foot, like if one of your feet is in the air, the other foot cannot start moving until that other foot has completely finished and touched the ground again. If you set it to like 0.8 or say 0.6, then your foot, like if you're moving, like the foot can actually start moving when the other foot is still in the air. And this says it can start moving when it's 60%, through its motion. So like once it's 60% through the motion, the other foot can lift up and start moving as well. So you get a period where both of the feet are in the air at the same time. And that usually happens when you're running. It doesn't happen when you're walking. That's like why it's at 1. But you see, when you're running, that value is 75%. And that's because, like, when you run, there's a period of time where both of your feet are in the air. There's gonna be a bunch of, like, there's like smoothing time for, like, like when it kind of transitions. There's step down angle. That usually influences, how much your foot tilts. So, like, if I set it really high, you see that's very extreme now. Like, the feet are essentially tilting a lot. I'm gonna change that back. There's stuff what happens to the hands, like there's the drag as well. This works the same, when you're in the air, except like when you're in there. There's the swing distance, how much they're kind of like doing this kind of motion. There's the offset, that's sort of like, the center around which the hands are moving. So if I set this, I move it upwards. When you start moving slow, your hands go to this pose and then they will swing around this point. So you can, kind of do that. I'm gonna move them back. There's the center offset, that's like usually when they like rotate, and the swing direction. And if I set this to say 1, they will only swing like, along the z-axis. But I could also, make them swing just on the y-axis if I really want to. So as you move, they're gonna be like, they're trying to move like an up and down, but they're also kind of getting stretched. Or I just do this, I'll do like this. There we go. You see, and now they're kind of swinging horizontally, which doesn't really make sense, but, helps kind of demonstrate the point. This is sort of like the direction in which they all swing. I'm gonna change this back to what it was. There's arc peak. I think the arc peak, that's like when it's doing the swinging motion, because the normal swinging, you have, your you have like your, center point that's around its swings, and then you have the direction. So say the hand, will swing back and forth, but usually you want it to kind of arc like this. So the arc peak is essentially like, it's a offset, so the hand will kind of go like this. Or maybe, it goes like kind of outwards. It's gonna be going like, and you're determining, that kind of like offset. If I try to increase that, I can like, say put an extreme value there. Then as it swings, you see now it's doing like an extreme arc where it's going upwards as it moves around. There's another similar thing, what happens to fingers, I can kind of curl them, change like, how they behave. There's what happens to the head, how much smoothing happens, the bobbing offset. So like if I change this, that's much how the head is like bobbing horizontally, like when you're moving, because like some people when they run, they will be like, some are more like stationary, so like people can move like different ways. There's a horizontal bobbing. There's the angle. So when you move, it can be like, doing this kind of motion. And set it back to 0. There's vertical bobbing offset. That's like, going up and down. And all of these are kind of combined, to produce the final motion. There's angle offset, that's like kind of going like that. So if you walk,
I'm looking
Oh, that's
straight right now.
oh, that's the offset. I want the angle. There we go. So you see, it's kind of like bobbing like that. The offset is like the default one. So like, for example, if you run, the offset, would be... Well, no, I mean like, not you. Generally, if you run, like you might tilt your head a little bit downwards, so that's your kind of base, and then like your head is bobbing up and down a bit. It kind of covers like, a lot of these. The important ones, like, well, this is kind of all important, but like, I kind of skipped over the foot travel ones. So the foot travel distance is, how much the feet actually move, like, how far they moved in this locomotion. So if I set this to be really low, and if you walk slowly, you see he's doing like little tip taps, because like the feet are not allowed to move too far. And the more I make it, the longer the stride is gonna be. So now I set it really high, and it's gonna be making really long strides. So I'm gonna leave it back. There's sideway distance ratio. I actually forget what this one is exactly. There's backwards distance ratio. There's the max angle, when they kind of like, how much they tilt. Turn influence, that's, when you're turning, how much that kind of affects the travel distance. And you also apply offset. So you can, for example, if you walk, now the feet are kind of like sideways, you can change the center. Usually just adjust the back and front. For example, if I set this to 0 and you walk, the feet can be like the 2 in front. It's kind of changing where the feet are being placed. There's the step height, it kind of changes, how upwards does the foot go when you walk. You see now he's like making big steps, but usually when you walk, like you don't actually move them upwards as much. Step down height is like, when it's kind of coming down. Step up power, that's kind of like, what shapes the path. So like it's essentially like a power that's applied to the height it would be. Step up velocity multiplier, this one's like interesting one. So like what this does is like when your foot is about to leave the ground, it's like this value is what makes it kind of spring up. And this usually happens when you're running. It's like when the foot leaves, you kind of spring off, and the foot is, starts traveling upwards before like you kind of move it downwards, to kind of place it back. And I set it on extreme values, so like the feet are just kind of shooting up. Let's see, where was this? Step height. I lost my bearings. Angular velocities, step down angle, that's hands. Am I blind? There we go, step up velocity multiplier. So I make this lower and you move around. You see the feet are still like blunk, blunk. Usually it doesn't happen much when you're walking, it happens when you're around, because when you're around, your foot like really springs up. So this kind of covers like, all of these parameters. You can also add, more of these gates as well. To kind of like, refine how it works at different velocities. You can change when it kind of transitions between them, because usually finding like good values, it's a balance between, realism, but also like, practical, because oftentimes characters, in VR, we actually move like way faster than you would move in real life, and making the motions still look real, it can be kind of like, challenging. So you have to kind of find like a good balance for these. But I think that kind of covers everything. Like, is there like anything like you think I should mention, or?
No, I think you gave a pretty comprehensive like overview of it. I think we could spend like all day talking about it, just because there's so much you can do. But like,
yeah, there's a lot. But yeah, hopefully this kind of helps. I'm gonna check the time. Yeah, I'm actually kind of running out of time, so I have to kind of cut it down there. But I hope this, this helped. This helped you kind of understand, like, the system a bit better and what parameters do. So, and we got a bunch of questions, so we should get into those. Well, there's 2 of them.
I think I need to respawn.
Yeah, you need to respawn. Fine.
I don't know if it was
This is fine. So yeah, that's kind of how that works. Just. I do recommend, like, if you wanna, watch some of my devlog videos on that, because I kind of play with those parameters as well. There's also like a visualization mode you can turn on. But anyways, the next question is from Platypus744. Hi, I was
think we
wondering
are.
if you could give a little. Oh, that's the one we just
Yeah, we
answered.
did that.
Sorry. So yes, that's the walkthrough. I hope that helped. Next question is from Bitkark IGN. I wanted to make a custom context menu background recently and wanted to fade it out like the rest of it when it opens, closes, when the laser is near edge. I found context menu component and lerp field that controls the fade. However, the solid context menu is on user rather than avatar, so accessing the field is impossible since the source won't work after switching sessions. Do you think there's a way I can achieve that, or should I make a GitHub issue? I don't think we expose it right now. Like, I'd probably make a GitHub issue because
I
there
mean,
should be nodes for access. Actually, let me just
if
do a
you
quick check.
if you make a custom context menu item, like it's gonna behave how all the other context menu items are on your like on like the circle here. So are you like manually injecting an item? Because that's the only time I could think of when that wouldn't happen. Because if you use the context menu item source components like you're supposed to, they will just add another item
Yeah.
and it will behave like the rest of them.
I think they're adding like a custom background to it. So I would probably just make like a GitHub request because we do have this node, but we don't have like one that like shows you how open it is. And I think that's something we could probably add. Like for the animation of it. So like, just make a GitHub issue. Like, I
Yeah.
don't think there's like any way to like really do that without any sort of like, hacking around.
I'll tell you what, if you make a GitHub issue, I'll do it.
There you go. Add more nodes. Add more nodes. But yeah, this actually covers all the questions. We got 9 minutes left. So if you got more, if you have more questions, ask them now, or you'll have to like put them to like to the next one next week. But since there's
don't ask like questions that are like, can you please describe your philosophy on the universe? Like
not near
just
keep this
not
for
near
a
the
start.
end.
Yes. Yeah, sometimes I get like people kind of ask like really complex questions when we're closing, and we're like we don't have time anymore. But I kind of like you're free to ask them, you're free to ask them, like the next time as well when we kind of get deeper into them. Erasmus is asking self-cleaning cache. I mean, it's on the GitHub. It's something we want to add, but it's like compared to other things, it's not as high priority right now. But it'll happen eventually. And if you like, want it to happen sooner, put like, upvotes on it. It's one of those things where it's like, when it comes to prioritization, it's like you can kind of get around the problem by cleaning the cache, yourself. It's not ideal, but you could get around it. Versus something like, for example, performance, you can't really do super much. We need to optimize things, which means, we give that a higher priority because there's like, not a workaround for it. And it's like something that's kind of, hurting things more right now. But we'll eventually want to like, prioritize like the other things too, especially once kind of some of the more major problems are like resolved. So since there's not too many other questions, I do want to like showcase this map because one of the things, oh, actually we got another question. Platypus744 is asking, there are some components called locomotion, animation, body collider on bones like hips. Could you explain their use? So essentially what those components do, like when your hands are being positioned by the locomotion system, it actually checks for collisions with the body. So like the hands will, not intersect your hips, they will not intersect the body, and whatever else you might have on your avatar. They're gonna be like, the hands are gonna be pushed out. What that component does, it essentially says, this collider, is meant to be checked by the locomotion animation. That way, any colliders, like for example, if you have like, like a custom menu or something, it will ignore that. It's only gonna check the colliders that are marked with that component. So, that answers that. And what I'm gonna do, this world, it actually uses like the new spherical harmonics to control the dynamic lighting. If you're checking this word out, I'm just gonna go back to the spawn if I can find it. There we go. there's a toggle here, real-time reflections. And what it does, it puts a reflection probe on your head and then uses that to control the ambient lighting with the new components that have been added. If I turn this off, you can see it still kind of looks okay, but like as I move around, it doesn't change. And then there's like this cave. If I go down here, I'm actually gonna change this to third person so you have like a little bit more context. If I go here, there's this cave and I go inside of it. You see, it's kind of bright in here. There's a lot of like, ambient kind of light. And this is usually, how the maps are, because there's like, shared global lighting, but like cave, like there's barely any light coming in, so it shouldn't be this bright. So if I go back outside and I'll go back to the spawn, if I can find it. Oh, there it is. And I turn this on, you can immediately see like, it's kind of darker here. There's like more contrast. If I come into the sunlight, things kind of become brighter. If I go into dark, it's darker again. And it kind of updates, the lighting based, where you are in the world. So it'll give you shade. It kind of just lowers it, this nice contrast. I'll go outside and everything becomes brighter. And then if I go into the cave and I go inside, it's actually properly dark in here. And the funny thing is, because like it's basing on the probe, so like if I go here, things like this, like they actually, oh, you can actually see it. Yeah, there's a camera that like doesn't render, but it renders in the preview. I'm gonna remove it at this point. If I open something, actually, let me spawn. Do you have anything emissive? Actually, I'm just gonna do a light. So I do light. This kind of illuminates. And if I delete it, it's dark again. And I get outside, and it's bright again. It's really, really neat. So this is like one of the things you can kind of, do. If I do the jump, that does it. You see like how the jump kind of changes the illumination too. It's a very cool new thing you can do with the system. It's not like you cannot do, since the ambient light is global, you cannot like, it kind of changes everywhere as you move around. It's like one of the kind of limitations, one we probably were gonna keep until we switch the game, like, the rendering engine. But it kind of, shows that you now have a little bit more control on the lighting in the worlds. And this map is like, making a really good use of it. But I was asking, this world is called Water Park. It's a published world. It's made by one of our team members, Rushen. And he did like a really good job. Like it's very optimized as well. Like it loads really fast. It's kind of cool. Like it's nice and sunny. He said like he actually built it in a water park that's like near him, so it was kind of an inspiration for it. And like you can just check it out if you go into the world browser and type water park. So definitely check it out. It's kind of funny being in here though, because like it's like in the middle of winter here, and now it's like nice and warm in here.
Virtual summer.
It's virtual summer. I mean, it's summer in Australia.
Yeah.
This is just just in Australia right now, virtually. But yeah. So that pretty much kind of covers everything, I think. So we don't have any more questions. We got about a minute and a half, so I'm gonna start closing. I'll also check if there's anybody to raid, because like we like to raid people. Let's see, anybody else streaming? I think there's only creator jam that I can see right now. Let's see, anybody else streaming Resonite? Oh no, there's Nuki-kun. I'll send people Nuki's way. She's working on the Avatar world, the community one. So I'll send everyone her way. But before we do, thank you very much for watching. Thank you, Sarah, for being around, help kind of explain things.
Yeah.
Serve as a guinea pig for the locomotion. Thank you everyone who supports us, like both on like Patreon and now Stripe. And again, If you can, please consider switching from Patreon to Stripe. Like, we get about 10% more from the same money you pay, which helps us a lot. And in general, like, everyone can, like, thank you for being part of this community. Thank you for making cool stuff. Hope everybody's kind of doing well, working on MMC stuff. I can wait to see what we've all made at the end of the month. And also, just to repeat the PSA, the legacy particle system is going away tomorrow. It's essentially gonna be gone. That's gonna finish that phase of the performance update. Every system's gonna be automatically converted to photon dust. That way, going forward, we just have this custom system. The audio system is gonna be reworked next, and once that is done, the big splitting is gonna be the main work, and that's what's gonna give us the big performance boost. And I'm very excited for that. So thank you very much for watching. Thank you for all the questions. If you're watching this later, you can also ask questions in our Discord if you can't make it. And I hope see you. I hope I'll see many of you at the next one. So thank you very much. I'm gonna get the raid ready. So raid Nuki-kun. Did I spell it right? Yes. Raid has been created. It's getting ready. Everyone ready? Say hi to Nuki from us. Bye-bye.
Bye, everyone.
There we go. Oh, we rated 46 people. Nice.